It's just
Okay,
different. We need to get used to it.
Okay, let's start with the class, and let's not lose so much time. Let's hope the rest of the class will connect sooner or later. Oscar, do you want to go to the randomizer or?
Why not? But I mean, yeah. Okay.
Pablo, mute your microphone.
Pablo. Sorry. Hello, hola a todos.
Hola, Pablo.
Sorry, before we start looking at websites and stuff, could we talk a bit about like how I know everything's still very flexible right now, but how the course might proceed?
Okay, as far as we know, Tomas is having a meeting with all the professors, and right now, until further notice of the government of Spain, we have a shutdown of 2 weeks. It might be longer, maybe not. We don't know exactly. So the course will keep as always, but we will have all the classes on the video conference. Luckily, the next incoming weeks could be done mainly in the digital world because we have inputs, outputs, interface, and applications. These are the incoming weeks. So actually, with your Arduino kits that you should have, each one of you, and also we also try to provide you like some electronic components on Thursday before we close. You should be able to do all the assignments. For the past week assignment, CNC week, like yesterday we had another class. I know they have an overlap, but we recorded part of the session. And you, as I state in the mail, you can always make the digital design. You don't need the lab for it. And you can start like also preparing the CAM files. If you have any doubts on how to prepare the CAM files, we have the tutoring hours, also stated in the mail. We are connecting every morning from 10 to 1. Each one of us, Oscar, Santi, Xavi, in turns. So actually, you have all the mornings that we are connecting the conference, so you can contact us and we can solve any doubt that you may have to solve your assignments. The timing of the schedule keeps as always. The difference is we are using Zoom or Jitsi, depends on the video conference right now. Is clear, Cesar?
I think the people who run away, and it's quite many of them, including me. I didn't, for example, bring my Arduino with me because I had like one backpack and that's it. So what do you recommend? To order a new one?
Yeah, order an Arduino kit from Amazon, like the Chinese Duinos that are like 30-20 euros, and that will solve many of your issues.
Can you send a link maybe later?
Yes.
Okay.
You have two types of kit. They are quite standard. You can find the short kit that is around like 30 euros, depends on the country. And you have the extended one. With this, you can do whatever you want, actually. This is a full Arduino kit with everything that you might need for everything.
Cool.
On the email, you say to send an email before logging in.
Sorry?
In the email about the tutoring hours, you say to send an email as always before.
Yeah, but also we are saying that we are connected all the time.
No, I think, well, the only thing is, so we have like the two versions of support. So we have like more final project type of conversation that is like long, in which we have like half an hour or 1 hour dedicated just one-to-one, and then the support for making the assignment. So for the support of the assignment, you don't have to send an email. We are going to be connected in the morning, and then it's going to be something shorter, like we expect 5-10 minutes. We don't want to talk big things in there. Then for the other ones, that is traditionally on Tuesday mornings from 10 to 12, that's the one that you send the email. Okay. And that still goes. Natalia and Caroline did that on Monday evening, and we had a tutoring session on Tuesday. and that should be like as it is now. Just think as the our presence in the teleconference in the mornings continues as if we were in the room somehow. Okay. Should we? Do you have any more questions, or do you want to ask anything else before we talk a little bit about this week?
Hello, yes. I just wanted to ask you maybe if you could be like more considered like until next week, since we're having design dialogues online on the 23, so it's kind of weird right now because we're like arranging what we're gonna do. At least for myself, I have done like some of the exercises, but I haven't uploaded anything in the webpage. It's just until the next Tuesday that we have design dialogues. So where I think all of us are like really working into that. That was the only thing I wanted to say.
Okay.
At least in the reviews, or just to let you know.
Yeah. Well, well, I mean, for me, I don't have any problem with that. Also, given the circumstance of the like lockdown and everything, I suggest that we still do the reviews weekly, no matter what happens, so that we keep motion and we don't lose track. But if there are special circumstances as in this week, of course, we are always humans and we can be somehow flexible. So yeah.
Thank you very much.
I don't know if you have any other opinion, Edu or Xavi, that you are listening. I don't want to impose or.
Just for the video conference, keep all the microphones muted, and if you press the space bar, actually unmutes automatically. Like, let's say it's a kind of a walkie-talkie, the space bar. Okay. That states for Daphne that has the microphone on.
Okay. So do you want to proceed to presenting something? Hello? Edu, Xavi? Should we go?
Yes.
Should we start?
Let's go with the randomizer, but maybe there's not too many people, so let's go in the order of the screens. Actually, my first screen is Laura, so do you want to present?
Hey, I think it's better that we go to another person because I didn't do anything. So, yeah.
And do you have any other progress on your final project?
Yesterday
have
I
you...
talked a bit with Edu about the Fab Academy project, and I have a more or less clear idea, but I have to work on it. So at the moment, I don't have anything to comment, but I will have in the next week. So yeah, we can pass to another one.
Okay.
Thanks.
Okay, next is Regina. Unmute.
Sorry. I don't have anything to show, but I did the assignment with the boards, and it will be uploaded soon.
Okay, you have something to show. You can share your screen. On the bottom part, you can share your screen in case you want to.
Okay.
What did you do?
The board. Give me one
What
second.
board? An skateboard or?
Snowboard.
Do you? Okay, so the file is ready, and you have already made all the footprints. No.
I have the board already.
Ah, you already milled it and sold it?
Yes.
Okay. Have you tested it?
No, I didn't solder it. I didn't have time. I ran away.
Can you show it on the screen so we can see it?
I'm really trying to find it. So,
Did you find any problem?
yes. Where is her screen? Okay. So this is the board I made. This is the PNG of the board.
Okay. I see the button. Okay.
I have 3 LEDs. I added the button, the LED, the FTDIs there. The problem I had is because I'm stupid, when I was milling, actually when I was making the mods files, when I put the, not the traces, I think it was the antenna, I didn't put the correct Z, I put it 0 by mistake. So at the end, it just scratched the whole board from one corner to the other. And it was ruined.
Okay.
But me and Josep tried to solder it back and it was kind of working, but we stopped in the middle because we didn't have time, the school closed.
Do you have your PCB physical that you can show in the webcam?
Yes, give me 1 second, I have it on my phone.
In case you didn't melt the PCB under the antenna, the board is going to still work. The only problem you will have is you might get much shorter range on the Wi-Fi. So you will need to get closer to actually the router.
No, I did it. Give me 1 second. Can you see that?
Sorry?
Can you see that or no?
No, I only...
No.
No.
You have to stop sharing your screen.
No,
Give me...
we just stopped to, yeah.
Now?
Right now, we only see the black and white PNG and your webcam. What are you trying to share?
The
She's
picture.
trying to share this.
In where? On the phone?
Sorry. Now?
It has shared on the WhatsApp of the group MDEF.
Yeah,
Okay.
I did, so it can pop up in my computer.
Yeah,
Yeah,
but you should open the screen of WhatsApp
Yeah.
or download the image.
Right now, you're only sharing the photo. You are not sharing your screen, Regina.
Fuck.
You can choose to send different applications. Okay, now we can see.
So as you can see, I scratched on the left side.
Okay, it's not
Milling of the antenna stopped.
okay. It's not a big deal. You can fix it. One good tip is actually take the resistor legs. If you have the resistor, you have the leg. Just break the leg, cut it, and use the little piece of metal to actually make a jumper, like a wire that you can solder. Or you can try also to solder directly. That also kind of works.
I tried a bit with Josep, but we didn't have time and I just left the board there.
Okay, don't worry about making your PCB a Frankenstein. The point is to make it work, not to make it look beautiful.
Okay.
Okay, in general, looks nice. You're gonna have a lot of work for soldering, that's for sure. But... Do you have a soldering iron?
What?
Do you have a soldering iron and the components? Do you have to took the components? Okay, in that case, kind of, you cannot do so many things with it.
No, I can't.
Okay. Also, I'm gonna send you another link. Actually, that board that you just made is really similar to this commercial board that most of you will have it. Let me look for it. There are different types. You have this one and this one. So also it's a board that you can buy. It's €9 and will actually do the same as the Arduino. The board that you will have to do is the Node MCU. It's the same microprocessor and has the USB connector directly embedded. So with this one, you can do Wi-Fi and you will be able to do the networking assignment without any problem.
Okay.
Okay. Georgia, just to answer your mail, Georgia asked me by mail if we could actually use a rubber powder from the recycled tires to produce 3D printing filament. Actually, Laura, we have conversations on thermostable filaments and thermoplastic recycling also, because it's also a little bit in her topic. As far as I know, you cannot do it because rubber is a thermostable polymer while polymerized. That means you cannot melt it back again. You can transform it, but crystallizes in a different way. The first time you actually produce rubber, the rubber crystallizes in a small, creating microcrystals in the polymer, and you can recycle by compressing, and the techniques you already shown me, Regina, but you cannot completely recycle as a, for example, PLA or ABS plastics. As far as I know, is the only things I know about rubber, because it's not a material we usually use. Okay, hello. Somebody's there. I hate talking to the wall.
No.
No, no.
Okay. Okay, EcoAlf. Okay, Laura, nice link that you just sent. EcoAlf is a Spanish company that makes clothes, trying to recycle most of the materials, and they use for making flip-flops. Actually, I think it's a similar technique that you already showed me in the paper, Regina, the compression heating one.
If you see the link I sent with the email about the needle machine.
Yeah, I have seen the link, and it's about how to cut rubber material. Cutting could be done with a needle. Like, actually, that guy is not needle cutting. Needle cutting is a completely different thing. It's using a needle as a cutter, just by cutting by high-speed friction. So as a really, really small end needle. So yes, rubber, we can cut it in the CNC without any problem.
I just bought like 10 kilos of different sizes of elastics.
Elastics?
And coming, yeah, like recycled, recycled rubber in different sizes. So I'm just gonna try and find ways to practice here.
Okay, don't use your home oven, just in case.
I don't have a death wish, Edu. My mom would hang me from the main square if I did that.
Okay, just in case. It was 300 degrees, no? The temperature of the rubber you needed, no? More or less.
The first one I sent you. No, it was a bit less, I think. It's 250.
Maybe you can buy a small toast oven, like the ones that are really cheap, that they might reach 200 degrees easily.
I had an idea, but I don't know if it's gonna work because we have this like I don't know, like the old ovens that are like built with bricks,
Yes.
and you put inside the woods to heat it up. And I was thinking of using that, but I don't know if it's gonna work.
The problem with that is you don't control at all the temperature, and you will reach easily like 400 degrees and more.
I know.
So you will have a problem of self-ignition of the material. Your bag can literally can light it on fire. So the problem is controlling temperature there. But in theory, it will reach temperature without no problem.
And
You
have
can
you
try.
seen anything about 3D printing with rubber powder?
Nope.
Okay, I'll send you some links because I don't want to keep talking about me without people waiting.
Okay. Okay, thank you, Gina.
Thank you.
Next one is Adele. Hello, Adele. I see you in the camera. You have to unmute. Unmute.
Adele on the left corner.
They just updated their meeting. Did you see, guys?
Yes.
Okay.
What does it mean?
We got an upgrade. We don't have a 40 minutes limit. So, okay.
Can you hear me?
Okay.
Yes.
Okay. Hello. Now we can hear you.
My laptop froze and it didn't appear the button. Yeah, I'm similar to Laura. I stopped around mid way in the design of the board, and I couldn't catch up since then. And yeah, it's a mix of everything. It's a mix of getting ready for the design dialogue, also having a small kid at home, and I will, for keeping my sanity, I will probably just get back on board until after the design dialogues, and then try to just do as much as I can to catch up.
No worry, we completely understand that, but also don't let, for example, the PC fabrication until the lab opens. So,
okay,
for example, you can finish the design and make the footprints ready for production. So try to save as much time as possible.
Yeah. I will try to find the tutorials that I like, and then I follow it, and
okay,
that's all I can do for that. And yeah, with the documentation, I will probably be a bit behind.
Okay. Any comments on your final project, how it's going, or how you might think to approach it?
Yeah, I talked to Oscar about it a few weeks ago, and he sent me a really nice description of a similar project. So I know, thankfully, I know what I want to and how I will have to more or less design and fabricate. And then I will have to also do the inputs and outputs part to learn about that as well.
Okay.
So yeah, I have it in mind. Just have to get there to actually start working on it.
Okay. So thank you, Natalia.
Hi. Yeah, I'm gonna share my screen. I did something for the CNC. It's not completely finished.
Okay. Thank you.
Yeah, can you see?
Okay. Yes, we can see.
Something. Well, it will depend on the size, if it's gonna be a chair or if it's gonna be a table. But I still need to finish this bottom part, and it will be glued, I think, together. And
I don't think you need the bottom part.
Well, yeah.
But it's, in case you want it because of the design, you might do it, but you don't need it. It's not mandatory.
Okay. Yeah, I
How
can
how you plan to connect actually the ribs?
glue.
We state no glue, no nails, no screws.
Then I don't know.
Okay, you might want to use, yes, as Andrea is saying, threaded rod. You actually drill. I'm gonna share my screen and draw. Okay, I cannot share in what you're drawing. Okay, whiteboard, share. So you see my screen?
Yeah.
So, okay, so this is the profile of your super stool, more or less. You can make some holes on it and
Yeah.
put a threaded rod. And if you check on your design on the profile, more or less, okay, best drawing ever, you will have your threaded rod wrapping everything, and you can use a bolt to actually compress all the parts between each other. You need at least 2. I will recommend that if you can embed 3. Another option will be actually that if you have your pieces that are like this, more or less, you can cut this part out, and you can have another piece that actually sits in place, clapping to each other. You insert it like this, and you have all the parts attached to this main part. This you can able to do it in wood, or you can use the option of the holes with threaded rod. I think this option is better. Why? Because in the profile, right now you have all the material stacked next to each other. So that means you will need a lot of material to actually make at least 30 centimeters, that is the minimum setting size in the width. With, if you see this technique, you can actually make like this on this element. So actually your profile is not anymore like this. Is you have one rib, you have the little spacer, and you have another rib, and you have the little spacer, and you have another rib. So actually you can make your stool much wider in case you want it.
Okay.
Okay.
Yeah.
So you have that part ready. Now is you need to think about the camp part.
Cool. And the nesting as well, right? Oh.
Yeah, but the nesting is actually first, before going into the camp, I will nest, because probably when you try to sit down all the parts flat, you will see that just making a small modification, you can save so much material.
Okay.
And look at the link that Santi added to the video conference. That is also quite nice.
Right. Cool.
Okay, thank you, Natalia.
Yeah, okay.
Oh, sorry, about the final project?
Yeah, I mean, I don't know. I talked to Oscar. For now, I need to do a lot of Grasshopper, a lot of testing and making. So I think I kind of like have it planned and just need to start and kind of go baby steps, you know. So yeah.
Okay.
Thank you.
Thank you. Santi, the Neil session dropped out, or what happened? Ah, you are with 2 laptops. Okay. Okay. Next is Wong Sadong. Wong, are you with us?
Yes.
Just a comment for everybody. Guys, we are having classes online, and we already commented, Santi, Xavi, and Oscar. it's really difficult to have a class with all the microphones mute. Of course, we need to have it mute, but without the cameras. It's really difficult because actually don't see anybody. We don't know. We are talking to the wall, and it's not
Yeah.
nice to keep talking for like 3 hours in a row. So I know that nobody wants to show their couch, but actually we are everybody in the same situation. So it will be nice if at some point we can see some of you. Okay, thank you. Juan, please go on.
Okay, so last week I make PCB board in KiCad. So, but it's not finished. So last week I cut this, something like this.
Okay. Can you keep the PCB closer to the webcam so we can actually see? Closer, closer, closer. Okay. You added the button and the LED?
Yeah, is it like bottom and LED? No, no. because that time I don't finish. I don't finish my button and LED. I will show you my skin. Sorry.
Yes.
But I will show you my skin.
So actually you finish your designs, but you designed, but you didn't cut it. You just cut it the normal Arduino without modifying it, no?
Yeah, it's normal.
Okay.
It's normal.
Normal.
Yeah, but in my design, it's like it have to adapt the size more because the size is not suitable with board to printing.
Okay. You design it too big for the actual.
Yeah, it's too big. I have to use time to adapt the shape to make it suitable to printing. So that time is gonna be close. So okay, so that time I use I printing ordinarily. It's like a simple board and pick up the component. Yeah.
Okay,
and for let's say for CNC assignment, I be in the file to the reference of my project. It's not I didn't make a 3D model yet. I have to decide. I have to make decision which one that I would like to make. So I would like to make a shell. Okay, I have reference. Wait a minute. I try to flip it.
Yes, we can see your screen.
Yeah. I try to make something like this.
Okay.
Yeah, it look like a shell to use in my room.
Okay.
My
That's
room is
nice.
like yeah, and put in my inside something like this.
Okay.
It's very okay. I have to measure the size of my process, and then I have to make 3D and make something like this.
Okay.
Something like this.
Nice.
Yeah, but it's not finished now.
Okay.
Yeah.
One, try to solder the ESP before tomorrow.
I would like to solder the USB, but do you know how to find machine to solder?
Amazon, like just put solder iron 30 watts.
Put the iron. I didn't solder. Yes.
Or let me just send you a link.
Oh,
You're
okay.
in Barcelona? Are you in Barcelona?
Yes, in Barcelona. Yes. I would like to buy it.
Yes. Just 1 second. This thing comes with tweezers or not? Let me see. You have tweezers?
Yes, yes.
Okay. This is a small kit that is useful and cheap.
Okay. Yes, here.
Yes. Just send you another one that includes everything you might need, like different points, station, tweezers, solder, paste, etc., etc., etc.
Thank you so much.
Okay. So who's next? Do you have any doubts or something? But I don't know how to take incoming weeks. Just to remember, all of you, tomorrow we have the embedded programming class from 10 to 4. Oscar or Guillem are going to lead that class. I think it's going to be Guillem, and Oscar is going to lead Friday class that is going to be on Platform IO also for embedded programming. What's the diameter of the milling wheel we are using for the CNC? We will use a 6mm diameter end mill. Andrea. If your design is complex and like you have work on it, we can have conversations on how to use other diameters. But usually the diameters that we use in the lab are 3, 4, 6, 8, and 10. Okay?
Sorry, Edu, that's in millimeters?
Yeah, millimeters. For the big machines, we don't use inches, only for the small ones.
Okay, the most usual one you do, at least to know, for the dog bones?
For the, we always use a 6mm because it's fast enough, but not too big, and you don't see the dog bones too much.
Okay,
and
thank
also, the point of having a 6mm end mill is in case you made any mistake in your file and one of the lines of code is wrong, that sometimes we supervise the file, but we don't see everything. The end mill breaks before damaging anything. So it's a kind of fail safe to have a diameter of the meat of end mill that size. Okay, what the thickness of the wood? The thickness of the wood I will put also in the chat, but the size of wood is 2.5 meters by 1.250 by 15mm thickness. Of course, you cannot measure the wood right now with a caliper, but I want to make sure that actually I know that in average all the woods are actually 15.2. So actually the real thickness of the wood is usually between 15.2 and in some cases is 14.9, but that's around the standard tolerance of that the kind of wood that we buy, the pine plywood. Okay. So let's go with Cesar. Hello, wake up.
I don't have any updates.
Neither on your final project?
I've been talking to Oscar about it, so I'm continuing to work on it. I think I won't need the lab for anything necessarily. I'm probably going to order a Raspberry Pi so I can do most of the stuff here. So yeah.
Okay. Nice. You have some Arduino or something at home so you can do the embedded programming or input and outputs, or you want to plan everything with the Raspberry Pi?
I have Arduino, but I think for what I'm doing, it's going to be better to be using the Raspberry Pi for my project.
Okay, just think about the Raspberry Pi. All the pins are 3 volts tolerant, not 5 volts. And some of the sensors you might use are 5 volts. Just take that into account.
Okay.
Okay, thank you. Andrea?
For the electronics class, okay, I'll just share you the link. Just give me a second. I did finish my board. I have it at home. The only thing is that I didn't check if it's working. I should at some point. But here's a link to my webpage so you can see like basically like it wasn't as easy as I thought.
Can you share your screen? Like it's better if everybody can see the screen.
Yeah. I'm not sure. It's because I have two pantallas, so I'm not sure if you can see what I'm saying.
You're sharing it right now. Business.
Okay, so with the KitKat, it was I guess it was the hardest part, mostly when the PCB, like the PCB side, when we had to order everything on the layout. And then the Inkscape was pretty easy. I did receive some help because I didn't know like everything. And the mods, we did it. So like before the Fab Lab closed, I had time to PCB my own. And I was running out of time, so Joseph helped me out soldering. I did some of the components, but he finished it. I mean, he put all of them, mostly.
Okay.
And I don't know if it's working. That's the only thing. I should try at some point.
Yeah, seems quite good in general. The soldering looks quite clean. The only thing that I will recommend you for the future when you produce next PCBs is make the layers, like the connections, the traces, thicker. They're really, really, really thin.
Okay. Okay.
So
Yeah, actually, like at the beginning, I was doing like the presetted KitKat. I was working with the presetted, and then I realized I had to change them. And because just 1 or 2 lines was like giving me some errors, I did change those 2, and I left everything else as it was.
Okay, with just a point on why to use thicker lines, thicker traces, is first, thinner the trace it is, easier to break it while soldering or milling. Another will be that actually thinner lines cannot transmit too much electricity, and by so they increase the resistance. So you have a really thin cable has much more resistance than a thick one. It's kind of the opposite what people think so. So actually, if you have to translate a lot of electricity, for example, the main voltage for the microprocessor, the one that comes out from the 5-volt regulator, that wire might overheat a little bit. In this case, we are working about really small power, so we don't care that much. But it's better. When that you check that your PCB is working, I recommend you that you cover the connector, the FTDI connector on the PCB with hot glue or epoxy, because the traces are really thin and you are gonna break it really easily.
Okay. I will. And for the CNC week, I did some sketches, although I'm still, I can show them to you. Okay. So it's just a small furniture to hold the vinyl records. And I think I'm going to do this one, but without the, like the feet.
Can you stop sharing your screen so that actually you will come bigger, please?
Yeah, sorry. ¿Dónde está eso?
Yeah.
Okay, so I think I will do this one, but without this. So it's just, and I'm thinking of using like the same idea as Natalia did. So it's putting all of them together and use a rounded wooden stick to put them together, and maybe something underside, as you said. I mean,
okay.
Yeah. And that's it.
Okay, thank you. Updates in your final project?
No, not really. I mean, like, I know where to head, but I haven't, like, at the beginning, I did have an idea of how it will turn out, but at some point, it's mostly about coding, and I would like to make something like a physical device, so I need to think about it. I don't know what exactly, but I do need to think about it.
Okay. Just in general now, guys, you have a lot of time to think. So spend your time wisely and don't watch too much Netflix. Okay, thank you, Andrea. Pablo, don't know if you're in the street, in your terrace.
Hola, hola.
Hola.
Yes, no, I'm in the balcony because, as Natalia was saying in another chat, now we can smoke in class, so that's really good. So I'm gonna show, let's start with electronics. Wait, I'm gonna share my screen. Share screen. This. So for the electronic week, I finished all the schematics. I added the button, the button and the switch.
Okay.
I was able.
Remember to calculate well the resistance of the LED.
I was using 100 ohms because it was the same that we used in the other LEDs.
Okay.
Do you say it should be more? Maybe 220?
That depends on the LED that you're using.
Okay.
Oscar, we haven't showed them how to actually take the data sheets, no? Of a component.
No. We gave like very little information, but no, that actually is going to be one of the assignments for embedded programming this week.
Okay. So yeah, what we just talked about is datasheet is the, let's say, the PDF on how to use and what are the characteristics of each electronic component. Everything in the world has a datasheet. Any kind of motor, any kind of pump. Also, even the LEDs have datasheet. In the datasheet, they inform you about the working voltage and the amperage consumption. And with that, you can calculate the resistor. So it's not a big deal with LEDs because they are really flexible and the resistor you can use. But it's good to start this week. You will start learning what is a datasheet and how to read it, because sometimes it's quite tricky.
Okay,
so
perfect.
It's okay. Can we see that screenshot? Yeah.
Yes.
The red one?
This one?
The red one, yes.
So this was the schematics. I added a LED with 100 ohms, and
We don't see. I just see your window.
The window of my face. Wait, because it's supposed to be sharing.
No, we don't see the screenshots in big. We just see the SP232 folder.
Wait. Okay, yeah. Then I'm gonna share another screen. Like, okay, the screen. Yes. Can you see the desktop right now? Sorry, here
yes,
was
we see Fusion. That is your CNC.
Yeah. Okay. So, Paran. This is what I was showing. Here's where I added the LED and also the button. For the button, I used a 10K ohms. That was like kind of copying this other button. I just changed the reset for another input, LED pin and the button pin. And I copied like the same schematics, basically. I was able to design it, and I added a little bit more of design in Illustrator, like these little plants and leaves and my name and some names for the reset button and everything. I was able to cut it. Wait, I'm switching to cam. Joder, ¿cómo cambio a cámara? Un momento. Stop sharing, I suppose. Ahí me ven, sí. So here it's
Okay.
here's the board. Here's the board. As I was saying, as Sandra was saying, I was able to cut it, but not to solder it.
Pablo, just for the future, we
Uh-huh.
always start. Just for the future, we always start soldering from inside to the outside. You just solder
Yeah,
the header.
no, I haven't. It's just
Ah, okay.
yeah, just at least for it to look a little bit better.
Okay.
Yeah, I know. But anything soldered, I have like the
Everything is fake in the internet.
everything it's fake. Yeah, I have the boom here.
Okay.
I was thinking in solder it. I have a soldering kit, but it's 110. So I'm gonna see if I get better an adapter or something.
Probably will not work. It's not about the like it will not hit enough if it's 110.
Yeah. So anyway, I have an ESP node.
Okay.
So I'm gonna use that for the class, and I'm gonna wait for the Fab Lab better to solder it properly when I come back. Now, what? Sorry.
No, sorry. Just I just want to mention something. That guys, this is very like impressive that you managed to make the boards. You are using an open source software that is being pushed by community, and somehow you managed to do all this edition or all these modifications on the board on other software like Illustrator, exporting, hacking, getting your way around the whole process. So this is a very important moment for you to document how you did it, because this will really benefit others like Fab Academy students and other people. So I just want to say that you, for example, Pablo or others have done a KiCad class, exporting with PDF, in a Mac, into Illustrator, editing. All this is super valuable because not many people have done this, at least in the Fab Lab environment. You know?
Yes. Also document, especially not step by step what we are doing, but the troubleshooting that you went through. Like if you had a problem, how did you solve it? Or like what was difficult for you, or what was difficult to find. Maybe you didn't know how to change properly the line thickness or something.
Yeah, actually, I had a lot of troubleshooting. Maybe because I call it like the guinea pig, so that was good because I was the one that checked that the FTDI was wrong, and also that the line thickness wasn't the proper one in the design rules. So in the beginning, when I exported to mods, it didn't work. Like mods wasn't able to cut it properly, so I went back, changed the design rules, and yeah, that was a really nice and cool learning. I'm really excited to see it working in any time.
Yeah, it's so silly how a small thing that is just blinking an LED with your own PCB like changes completely your world and empowers you so much.
And even as Oscar was saying, export it in PDF and Illustrator, because PDF and Illustrator has a problem, and it's that the drilling holes are not made properly. So I made them by myself again, asking which was the thickness that it should be. I think they're like 1 millimeter, using a rule that told me like the thickness of these little legs. So I made the drilling holes were made apart. They weren't made they weren't export properly from the PDF from KitKat. Now for I'm gonna share my screen again. For the CNC assignment, I followed that tutorial I found to create this tool. That was my first step, at least to learn how to do it. And it was really nice because I did it parametrically. So actually, when you were saying that the tool diameter was 6 millimeters and the wood was 15.2, I can change anything in there, and it would like automatically change it in the whole design. I just wanted to ask something else. I have a parameter called clearance, and I wanted to ask you how much clearance should I leave? As I understand, clearance it's like the level of mistake or error that I should add a little bit more of space so that it
Exactly.
doesn't fit too.
Yeah, this is about tolerance and depends mainly your material. Can you stop your screen for a second? I want to draw.
Yes, sure.
Thank you. So, okay, let's go to a new one. So when the end mill is cutting, in theory, let's say we cut a line. This is a line, a straight line. And in theory, this is supposed to be the same as the diameter of the end mill. It means 6 millimeter in this case, no? Actually, with the end mill, what we are doing, the end mill in small, sorry, is the opposite, is like cutting the material. It's like a big spoon, small spoons taking the material really fast. So when you touch with this point, the material gets slightly compressed. So when the end mill passes by, after passing by, the material gets uncompressed. So actually what you get is a slightly thinner section here. So actually your material expands on the sides. So if you get a cut, if this in theory should be 6 millimeter because the end mill is 6 millimeter, for wood, usually this value is around 5.8 to 5.6, depends on the amount of material. So that means your clearance is around 0.2 millimeter in average on each side. So if you have a design that needs to be 100, you actually need to make it slightly smaller, so when the material expands, you actually get that. So you don't need to make it 100. You need to make it 99, usually 0.8 or 99.6 or 5, depends a little bit on the material. That's why it's really important, and this number depends mainly on your material, the material that you're cutting. So when you design something, it's really important to make a press fit joinery test before, so you actually know the amount of material expansion. It's like it will be the same as the laser. The laser, when you're cutting with the laser, you make a curve. So actually you are eating more material. With the CNC, it's the opposite. You are cutting actually less material than you should. It's an opposite curve.
Okay, perfect.
Okay.
Wait, I'm gonna share it again. Where is it? Okay, so I'm gonna change that value. I also learned how to do, wait, the dog bones. Here they are. They are also in the lower part. And I tried to lay down. I was following a tutorial yesterday to lay down, like to see
Pablo,
the.
think that you can also don't go through the material, and the connection to the plate could be done with a pocket. So you can actually cut only 10 millimeters, so you have the connection under it, and you don't see the connection on the top because you can leave 5 millimeters on the top plate. You know what I mean?
Okay. Yeah.
You can hide that joinery in case you want.
Yeah, that could be a good idea. Here you can see also the dog bones. But what I really want to build, I was trying to follow a tutorial. No, this one I did it by myself after I did the other tutorial. It's like a little desk for the computer, because that's one problem I'm having here, that I don't have like a place to study. And I was also thinking, because this wood, I don't know if I'm gonna be able to put it well. Anyway, I'm not sure if I'm gonna leave it like outside, or maybe like in the inside, like these ones. Actually, I like how it looks. In this one, I haven't done the dog bones yet, but I like how the joinery looks. I think that looks kind of crafty, which makes it like interesting. I was worried because now you're saying that we have 250 by 120, but
No. Sorry, that is the full material of the wood. You have half of it.
so we have 120, 120.
120, exactly. Sorry if
Yeah.
I made that.
No, don't worry. So I'm gonna have to sacrifice some parts of the desk, maybe the lower table or something. I'm not sure about how to check how much structure do I need, because maybe I don't need these legs, or
In your case, what you have is something that is high and thin. You want to have lateral stability.
okay.
So right now you need to have, if this is the section, sorry, like what is the camera? Ah, it's here. Sorry, this is if you have like this, the
Yes.
two main body, you
Yeah.
need one reinforcement in the direction, but also you need like 90 degrees counter connections. So actually with the bottom part, you kind of already have it.
Okay.
But if you have a vertical part between the two horizontal layers,
Like in the middle part?
No, go up, go up, go up. Here, if you have a 90 degrees vertical plate between, like, let's say a backdrop for your drawer,
okay,
it will help a lot in the stability.
Okay. Do you think that if I have the lower part and the middle part, no, the lower part and the upper part, I still need the middle one?
Uh, yes, but it's not mandatory, but helps a lot in the stability. And actually, it will help much more if you connect it parallel to the ribs, like not horizontal.
Parallel to the ribs. Ah, you mean that if I have like this inclination,
Exactly,
like this one, like the lower one.
exactly. That will help a lot.
Okay. Yeah, anyway, I think that I could get these pieces from scrap material, because
For sure.
I was trying to lay it down and it's not fitting. I'm gonna try to make it, maybe, I don't know if make these parts thinner, or, but yeah, I had a lot of fun and a little bit of sleep while doing this. So this is where I am right now with my final project. I had a personal meeting with Santi yesterday. I have been speaking with Oscar a lot, and we were talking about doing like one first step of the final project for the design dialogues, but now that it's not gonna happen, like I don't need it. But anyway, I was talking with Santi yesterday about how to build like a little box. Wait, I'm gonna stop sharing my screen. Like a little box to take pictures of the plants in the same lighting conditions, to have to teach an ML and like an AI. And with Santi, I was also talking about how to build like a little box to grow plants inside, that it only you can adjust the light and the water, and that's it, basically connected with sensors and everything. But we were talking about materials, but we were gonna talk next week when I have a little bit more of design.
Oh, okay.
So that's it by now.
Thank you.
You're welcome.
We are running out of time, but we are seeing a lot of people today. Let's go with Daphne. Someone? Daphne, are you there? She has fallen asleep, so let's go with Zui.
Hello.
Hello.
Okay, so
In terms of PCB making, I will share my screen. Okay. So in terms of PCB making, I am at this point. I need to fix this.
Okay.
And then I don't know what I will do because I don't have a milling machine. So maybe I will leave it at that point until the
Don't worry
problem
about that.
happens.
Just try to finish the design and check
Yeah.
that it's working properly on fan modules. Like you can do a lot of things. For example, finish the design, try that it works well in fan modules, and get the file ready. So actually, when the lab opens at some point, like maybe 2022 or something like that, you might be able to cut.
And
Finally, some realistic.
in terms of CNC, my idea was to make an interlocking wooden structure. I was thinking something like, I saw these references from example, the Wiki house,
Okay.
which is this house that all the columns, etc., are interlocking and super modular and super. But what I didn't like about it, I think it's a bit too complicated. Like they make basically 4 different planks for each column. So I guess I wanted to find an easier system to make the
Actually,
structure. So
the
yeah.
legs you have designed are actually really thin, and the material we are using is 15 millimeters, so that means it's quite thin too. So if you want to go with the design that you have, you need to use double amount of material. So that means you need to stick 2 layers to each other. So actually you get 30 millimeters in profile, not 50. And actually that's what happened, for example, with the Wiki House. What they do, stacking 2 layers of wood. First, because getting thinner wood is cheaper. So actually, if you design a system that you can stack 2 pieces together, you can reduce the pricing of the material. And also cutting thinner pieces is faster than cutting thicker ones.
Okay. So maybe it's a good idea actually to continue in that way as the Wiki house.
Yeah, stacked wood is quite common. And in case of table legs that you want to have like thin legs as much as possible, helps a lot. I not that long ago, I watched a table that I like it a lot. It's actually the tables of the cafeteria of the AAA School of London. And it was a quite good design. So let me try to find it. Yeah, here it is. Okay, I will show you. So you see, actually, it's using one panel in one direction and the other panel, but they are not stick exactly at 90 degrees. One is tilted to each other. You see it?
Yes.
So that helps a lot in the reinforcement because this panel is tilted. It's not perpendicular to the floor. So actually helps a lot for the stability. I think this design is open source, but I don't know where exactly it is. So actually there are a lot of designs. I don't know if you know how it's called, this page of open source furniture. I have to remember.
I was also looking a lot at these nice joints that
open desk.
Yeah, exactly. Like memory is getting worse with age. Open desk furniture is really well designed, but that also means that it's not that easy to fabricate. It has a lot of details. Sometimes it's double side cutting, but it's a nice page to show us, to see as a reference. And think that actually these tables, some of them we have in the Ajax in the office because they are really resistant. So think that they are using thicker materials because this furniture is meant to last a lot of time. So maybe you don't need to make it last like 5 or 6 years. You can reduce a little bit the thickness of the material some places, etc.
And I was also thinking to do something with these joints that also Niels has on the page of the CNC Week.
Yeah.
I don't know, to find somehow maybe ways to implement them in this design that I'm thinking. I don't know how.
Actually, I love, especially that's something that almost nobody of you mentioned already, but I love to actually mix 3D printing and CNC. I think it's really, really powerful. I'm going to share with you another picture. Because actually, if you use a colorful joinery, enhances the materiality of the wood, and it's a really nice design trick. For example, let me share this into my Dropbox, and can I attach files into here? Let me see this. I'm sending the file somewhere. One second. Can we share files here in the chat? Yes. Okay. I just send it on the chat. I can also share. Well, you can share. You can, if you open, we can all see. It's a shelf that actually has 3D printed nodes. In this case, it's using like circular profiles of wood to actually make the wood connection.
I don't see the file.
No? You are talking with Pablo privately. You need to change to everyone chat.
No, I've had it. Okay, where is it now?
Go to the chat. To Pablo, don't choose Pablo, choose everybody. No?
Ah,
Everyone.
Thank you anyway if you wanted to exchange something.
But I don't see again your file, Edu.
Okay, stop sharing the screen and share mine.
Yeah, I'm sorry. Ah, nice.
So for example, you can see you can make 3D printed nodes or 3D printed joinery and use pieces of wood to actually make a connection between them. We would love to actually see some kind of joinery with wood at some point too. For example, here, sorry, if you check closely, actually you see this piece of wood has been cut with a pocket that sits exactly on the joinery. So yeah, it's not press fit, but it's almost kind of press fit or kind of worked a little bit of joinery. Okay.
And a last thing that I was thinking about is maybe a way to make
Andrea share also with you some links that are really nice. That is the playwood. This also 3D printing joinery with wood.
I was thinking of the Volta Catalana, this Catalan vault, and finding a way to make a structure of wood and make some pieces. I don't know from what material, but somehow interlocking also. So finding an interlocking system for that also.
I will recommend you to don't go into that direction.
Okay.
It's really complex, and actually, if you are interested into this, like ITKE school has a lot of research work of PhDs actually doing like bolts made out of wood with cutted joinery, CNC cutted joinery. But the users
Who has a lot of that?
I think it's ITKE school.
Okay.
Let me find the papers if you are interested in that, because it's a PhD research that is going on. Application research, strengthen all documents to read.
Guys, it's 3:30.
Oh yeah,
classes.
it's quite late already. Okay, let's have the bio break. Everybody's okay?
Mm-hmm.
No, I'm not okay.
We don't care about you, Oscar.
Are we connecting to the other link after this? To the official
Yes,
one?
you need to connect to the other link.
Can I actually show my design?
Or not?
Sorry? Who was speaking?
Caroline. Sorry.
Okay. Like we hear you really, really far away from under the sea.
Can you hear me any better now?
But so, but let's go on.
Can you see my screen?
We don't see it. Yeah, now we see it. You want to review your PCB design, huh?
Yeah.
Okay. I clearly don't hear it.
Can you hear me?
Yeah, no.
Okay, that I'm putting these like components on the outside of this.
Mm-hmm.
And is this space right here like an okay amount of space to attach the thing later?
Sorry, I'm having some dropouts from your side. Don't hear completely.
Is this space right here, is this an okay amount of size to attach the other piece to later?
What do you mean? I don't understand what you mean by attach another piece.
Don't we have to connect those boards that we made to this at some point, or no?
Yeah, but they connect to the FTDI SMD header that you have on the top.
Oh, okay, okay.
That other board will be used to program the board, and those on the top right corner you have the connector. And then if you make other boards for sensors, you will connect them to the vertical headers, the yellow ones.
Okay, so for now, this is like on the right track then?
Yeah. So.
Well, you have two regulators. You only need one.
Oh yeah, that's true.
Okay.
Yeah.
Probably if you change the reference, that's why it got put in. If you go to net, the net classes, like if you work on imported, on the top, if you click on the icon that says net on the top, as if you work on import the net class, exactly. When you click here, put the delete extra footprints and update PCB. Yeah, and now close. That's it. Yeah, you probably changed the footprint for the regulator. It's one component that is used to power the ESP. Because you remember we made that mistake and you had both footprints in the design, but now it's fine.
Okay. And then just another question about the CNC. Does our piece have to have, it has to have some kind of connecting joints? Like it has to be pieces that connect in some way, or it can be one piece?
No, they are all all one piece. You will normally this come You mean the headers, right?
No, I mean for CNC, not for this.
Ah, sorry, I don't get the question fully.
Like not for this, like the next week assignments for CNC. When we are preparing, like when we go to cut, does our final piece have to be something that like has like joints and connectors, or can it?
Yeah, the idea is that you make something that doesn't use nuts, bolts, or glue or anything like that, or
Okay.
nothing like that.
Okay. All right. That's my only questions. Thank you.
Okay.
I don't even know how to get back to this.
Okay, so guys, I think it's time to switch to the class. Take a little time if you want, just leave it there in the meantime, but make sure that you visit it. We are closing this one. I stopped recording. Thank you.
Thank you, guys. See you in class in 5 minutes.
Thank you.
Gracias. Ciao.
Bye.